All right, guys, the only other example we have for the week is this one on page 503, I believe, and it's number 18, which will help you with 21 and 19 and those types of problems. So we're given systems of equations, and so basically what we're talking about is the fact that, well, let's say we have an ellipse and then we have a line. A straight line could go through it, so you could get an intersection at 2 points. You can get an intersection at 1 point, or you can get an intersection that's completely away. You're going to get one of those three options. And it could be a hyperbola, you know, something like that. It can be any types of shapes or ellipses, circles, parabolas with a straight line. It could be, I mean, it could even be an ellipse with a parabola. And how many solutions are you going to get? You're going to get 4 different solutions. So rather than having to graph these things out and figure them out, there's a way that you can take your systems of equations and utilize them. One of the ways is to move everything to one side on both of them and then set them equal to each other. But this one doesn't work that way very well. So the other type of way is by substitution. So we're going to call it substitution method. All right. And so what we're going to really do is we're going to look at these things and so say, okay, what variable can I solve for, and then plug it into the other one. So I'm looking at this. I got a y squared and a y. So anything I plug into here is going to, I have to square it. So I really don't want to solve for y, because then it's going to make a big number that I got to square and do work with. But I can plug in x. I have one x here, and if I can get rid of this x and make it a y somehow, I can get rid of all of this. So I'm going to take this equation here, and I'm going to solve for x. So if I rearrange this, I'm going to get 2y, I move the 10 over, equals x. So now I have x equal to 2y minus 10. Well, if I take the next equation, y squared minus 4y equals 5x plus 10, x is no longer x. It is 2y equals 10. So I can take this pink highlighted equation and I can substitute it in for x, because they mean the same thing. It's like if I said x was equal to 2, you would plug in a 2 there. But x doesn't equal 2. X equals the quantity 2y minus 10. So we just rewrite this thing. And we put the 5 there, and then we insert 2y minus 10 plus 10. And then if we finish the math out, we get 4y equals 10y minus 50 plus 10. We get y squared minus 4y minus 10y, I move the 10 over, equals negative 40. So I can clean this up, move this up even more. So I keep cleaning things up a little bit as we go. And we end up with negative 14y plus 40 equals 0. Well, I can factor this. You can do your box method, your area model. You can do the big X method. However you want to factor, it doesn't matter to me. I'm just going to do it where what multiplies together to make 40 but adds to make negative 14. Y minus 4 and y minus 10 equals 0. So y is equal to 4 and y is equal to 10. So I have my y values. I just need to find my x values. So I'm going to go back up to this equation right here, because I know what x equals. X equals 2y minus 10. So therefore on the first one, it's 2 times 4 minus 10, which is equal to negative 2. And x is equal to, on the second one, 2 times 10 minus 10, which is equal to 10. 2 times 10 is 20. So now I have my two solutions. My first x value is -2, and my first y value is 4. And then my first x value is 10. My second x value is 10. My second y value is 10. So these two equations cross at -2 and 4 and 2 and 10. So that's kind of how you solve for those two different equations.